All right, we can see here the derivative, the general power rule at play again. We can cover up this inside function and call that the g or the u. And then we just have g of t in terms of u. G of u would be u to the ninth. So that's our outside function. So this is outside function. The thing in the box, whoa, is the inside function. But notice with this one, our inside function is a quotient rule. And so it gets a little bit more challenging as we kind of power stack rules on top of each other. And that's where it gets helpful to do that one step at a time. So we're just going to take it slow, one step at a time here. So we're going to find, first of all, let's get a reminder of what the quotient rule is because we're going to apply that. So reminder, the quotient rule. That's where we have f over g. The derivative of that would be the low d high minus high d low all over low low. And then when we see those, and then from there, once we see the d's, that's where we have to do calculus. And when we see something without a d in front of it, then we just copy it straight down. So let's jump in. Okay, so our first step is dg in terms of t. So first thing, I'm going to use that general power rule, treating that inside function as just a dummy variable. So I'll bring the 9 out in front of whatever it was on and make the exponent 8. And the thing that goes inside is untouched. So I just copy it down. On the first step, I just goes inside the exponent. And then on the outside, that's when I multiply it by the derivative of the inside. So the derivative of the outside with the inside just copied in times the derivative of the outside. So my first piece here is done. I already did step 1. I already found the derivative of the outside. I don't touch that anymore. Calculus is done on that. The only thing that might happen to that now is algebra, but that is going to be part of my final answer right there. So that piece is done. And then, but I still have a D here. So this D tells me, oh, I got calculus to do. Okay, so I gotta do quotient rule in this one. So this is I'm actually gonna move this down a bit so we have enough space to do our quotient rule. And that is gonna be times, and I'll do a quotient rule. So I'm copying this formula in here, not just the G, but the whole thing. So I go, my low is the 2t plus 1. My high is the t minus 2. So that's low d high minus high d low all over low low. So I start with the low and I end with the low. Low d high minus high d low over low low. Okay, equals, again, the first part is already done. There's nothing else I can do to that. So we might do some algebra to simplify later, but the calculus on this one is done. So I'm just going to copy it down. It goes along for the ride. Now I multiply by this quotient rule. If I don't see a D, I just copy it down. That means I'm already done. There's nothing to do to that one. I'm just copying it as is. Oh, I see a D. That means I got calculus to do. So I got the derivative of t minus 2 is just 1. And then I have a t minus 2 with no d in front of it, so I just copy it down. It doesn't, no calculus to do there. And then I see a d dx. So follow those d dx's. Whenever you see d dx, that's where you have something to do. So the derivative of 2t plus 1, that's just 2. All over 2t plus 1. Notice that that denominator on the quotient rule, there's never a derivative there. It's always just the denominator squared. So it adds a little bit of a mess algebraically, but it doesn't add any calculus. All right, so now I'm going to simplify. Okay, oh, my calculus is over. I don't have any more ddx's, so calc over. Now I'm just going to simplify it. It's still really ugly, so I still got some simplifying to do for sure. Just doing some calculus now. So I have 9 times t minus 2 over 2t plus 1. There's nothing I can really do with that just yet, but maybe we will in a little bit. Let's simplify this crazy fraction first. Distribute the 1's and the 2's, so I get 2t plus 1 minus distributing the 2 and the negative. Let's distribute the 2 and the negative at the same time. So distributing a negative 2, I get negative 2t plus 4. So bringing that 2 out in front and distributing negative 2t into that t minus 2. All of that over 2t plus 1. I can simplify the numerator a little bit more. And I also see, as I'm writing this, I also notice that this denominator is the same as this denominator. So it would be great if we distribute that exponent to the numerator and denominator separately so that we could combine those. So I'm going to rewrite this one to the 8th and the denominator to the 8th so I can treat them separately. I'm sorry, forgot a square here. So just simplifying this numerator, 2t minus 2t, those t's go away. 1 plus 4 gives me a 5. And then I still have the 2t plus 1 squared in the denominator. But now just multiplying straight across, I multiply my 9 and my 5, and I get 45. And t minus 2 to the 8th. And in the denominator, I have the same binomial here, 8 times here, 2 times there, so that's a total of 10 times. And there's my final answer. So at this point, as calculus gets a little bit more rules on top of each other, it's easy to kind of lose track of what we're doing here. So as a reminder, what did we just do? We just found the slope for this line or this curve at any point t. So you can give me a t and I can tell you the slope of the curve at that point using this function. So that's what this is. So this is really just a slope.